Worked example 6.2b, we've got a proton and it's here next to this plate. It's positive plate, negative plate. So when that plate gets switched on, there's going to be an electric field here. And that electric field shows the direction that a positive charge would move. So this positive charge is going to zip across here to the negative plate. Repelled by the positive plate, attracted by the negative plate. And it wants to know, first of all, the force acting on the proton due to the electric field. So I've got my little diagram over here. Remember when you're setting out for your exam, the diagram could be worth a mark because it shows your thinking. So don't skimp on doing a diagram. I've written down here, like a good girl, what things I've been given in the problem: the electric field strength, the size of the charge. I was told it was a proton, so that's going to be plus 1.60 by 10 to negative 19 coulombs, same size as an electron, just a different sign, and the mass of a proton. So it's pretty straightforward. We're looking for force, and I've got electric field strength and I've got charge. I'm just going to use E equals FQ. Rearranged, and again, this step is worth 1 in the marking schemes on the exemplars. So don't skimp, don't muck it up. It's pretty straightforward. Substituting in those values, again, worth 1 mark. So don't go doing something without showing your working, because if you stuff up your calculator, which is easy to do with all these powers, you're not going to get anything, whereas you can get 2 easy marks by showing how you rearrange the formula and how you substitute it in. Doesn't matter whether you substitute in and then rearrange or rearrange first and then substitute. All right, so that's pretty simple. I've done a little check because powers, lots of powers gets tricky. This one's not so bad, but later on there's going to be squaring. So a little check, yep, by 10 to the negative 16, I should be expecting that's actually closer to 10 to the negative 15, but within 10 times, so I'm happy with that. Then I want the acceleration. So I've got the force, I've got the mass, so F equals ma to give me the acceleration. Again, I've done my little power check over here. 11, oh, perfect, worked out. Don't forget your unit as well. Just be thorough when you're doing your setting out. So I now have to work out time. So it told me that at the start it was stationary. So u equals 0 meters per second. I've just worked out the acceleration, and it told me it's going to speed up to 2 by 10 to the 5 meters per second and wants to know that time. So v equals u plus at. The u will disappear because it's 0. So t is going to be v on a. Little check of your powers. Yep. No, that should be minus 6. Righto, so that worked out easily as well. And the last step wants to know what distance it would have travelled to get to that speed. So s equals ut plus a half at squared. The u is 0, so that gets rid of that. So it's a half at squared. This is where checking your powers comes in handy. So I've got 3.83 by 10 to the 11, so that's close to 10 to the 11, so I've got 11. 5.22 by 10 to the negative 7 is actually, we would shorten that to 10 to the negative 6 because you'd round that one up to 10. And then you're going to square it, so 2 times negative 6 is negative 12. Negative 1-ish I should be around, and when I calculate it out, yes, that's actually 5 by 10 to the negative 2, which would be rounded up to 10 to the negative 1. So yeah, my little power check has worked out.